Alright, in this video, we first want to just define exponential functions. So we say that an exponential function with base b, where b is a positive value and not equal to 1, is a function of the form f of x equals a times b raised to the x power. And we call a the initial value of the function, and b is known as the base. And so if you recall for a moment, question 1, part b, our balance equation was 100 times 1.15 raised to the t power. So our initial value a is 100. That was just our initial balance in the account. And then the base b is 1.15, and that came from the fact that we were increasing our balance by 15% every month. So we were really repeatedly multiplying by 115%. Okay, now also the variable t, notice, is up in the exponent position, so hence the name exponential functions. And lastly, why do they not allow b to equal 1? Well, if b were 1, you just have 1 to the x. And so that would just equal 1 for any value of x. So in fact, there, your function would be a constant function. Okay, so that's why they rule that out. Okay, now I put linear functions and their form just directly below, and typically we write these as mx plus b, but I wrote it as a plus bx just to compare them to the form of an exponential function. And here a would be the y-intercept, which is also the function's initial value. And remember the balance equation we had in 1a, it was 100 plus 8t, so that 100 was our initial balance, and then the b value here for the bx, that's just the slope of the function, and in 1a that was just the $8 that we were repeatedly adding, right, because we deposited $8 at the end of each month. Okay, so for question 2 on the worksheet, it says to fill in the blanks, and it says a linear function has a blank rate of change. Okay, so like in part A, again, that rate of change was $8 each month, right? And that's of course just the slope. And the key thing there is that for a linear function, that rate of change is constant. You're just always contributing the same amount, right? So again, the balance, just $8 every month. Now, exponential functions, on the other hand, did not change at a constant rate. We saw there that actually every month we were depositing a little extra, right, on top of what we had the previous month. But what is constant there is the percentage change, right? We were applying a 15% change each month. So here I can say exponential functions change at a constant percentage. That's the key distinction for linear and exponential functions. Now we'll talk about the graphs of exponential functions in more detail, but for the moment, if you have a linear function, since it changes at a constant rate, right, their graphs are just straight lines, right, constant slope. But for an exponential function, since the rate at which the function is growing is itself getting larger, right? So that, say that dollar amount that's coming into our account month to month is itself getting larger. These things will have shapes that look something like this. Okay, they're going to slope upward. Okay. The last two parts here, it says linear functions are blank and exponential functions are blank. Well, what I'm getting at there is that, you know, for a linear function, we're just repeatedly adding some amount. So there in 1a, I was just adding $8 repeatedly month to month. So in that sense, these linear functions are additive, whereas exponential functions are what? Well, there we were repeatedly multiplying by some fixed amount. In that case, in 1b, we were multiplying by 1.15 repeatedly. So these things are multiplicative. All right. So that's going to do it for this problem, and I'll see you next time.